Well, I just got back from karaoke. I lost. So let's look on page 48. I'm going to fill in the steps for actually graphing a linear inequality. So we're looking on page 48. It's the last topic in this packet, and we'll be rid of it. All right, so page 48. This is what it looks like, page 48 in your packet. All right. What is a linear inequality? It's an equation. I left out a phrase. It's an equation of a line containing one of these symbols instead of an equals. Okay, what does the solution look like? The solution is a half plane, and that's a fancy way of saying the shaded part of the graph or the shaded half of the graph. So you saw in the last example, in the last page, you end up shading either above the line or below the line. Hold on a second. All right. Now, here is a linear inequality right here. It's got a less than sign, and you're supposed to check which of these 4 points, and maybe more than one, are actually solutions to that. And the way you do that, remember, this is your x and this is your y. Plug them in and see if it works. So 2, here's the x. That's where the x lives. I'm going to plug in a 2 minus 3. There's a y. I'm going to plug in 5 where the y is. Is that less than 15? Well, let's see. Is 4 minus 15 less than 15? Is negative 11 less than 15? Yes, it is. So why don't you take a minute and see if these are also solutions. All right, if you're back, once you try these 4, the 2 on the ends worked, but the 2 in the middle did not. So 2, 5 was the solution, 0, 0 was, but the other 2 were not because they did not work in that inequality. Now, here are the steps for graphing an inequality. Step 1, you're going to put the inequality in y equals mx plus b form. That's how you graph lines. And be sure to flip the inequality if you ever multiply or divide by a negative number. When you graph the line, you're going to use a dashed line if you see less than or greater than, but you're going to use a solid line if you see less than or equal to or greater than or equal to. You're going to shade above the line if the symbols are greater, and you'll shade below the line if the symbol is less than. Now let's put that into play here. Let's graph this one right here. I'm only going to do 2 examples, and that's it. All right, we need to get y by itself. So we got to move the 2x to the other side. All right, so that's going to be negative 3y is less than negative 2x plus 15. You're going to divide everything by negative 3. Remember, that causes the sign to flip because you're dividing by a negative. So y is greater than 2/3 x minus 5. So there's my equation. Y is greater than 2/3 x minus 5. Let's go over here and plot. Let's see. 1, 2, 3, 4, 5. 5 is all the way at the bottom of the graph. And I got to go up 2 over 3, up 2 over 3, up 2. Went off the graph there. All right. So I can only make 2 points. What type of line do I use? Well, it's only greater than. So I'm going to use a dotted line, a dashed line. And since y is greater than, that means you shade above the line. So you're going to shade above the line. All of this is part of the solution. So you're coloring in almost the entire thing. All of that's shaded. My shading is not very neat, but it doesn't have to be. All right, one more example. That's all you need. This is not very hard. Let's do number 4. I only need to do 2 of these. All right, let's see. Move the x to the other side. We got to get y by itself. Let's move the x to the other side. Negative 4y is less than negative x plus 8. I am dividing by a negative, So I am going to flip the sign. Remember, don't flip the sign if you're not dividing by a negative. Y is greater than, and that's going to be 1/4 x, because there is a 1 in front of that x and the negatives cancel. 8 divided by 4 is -2. Again, this is going to be a dashed line. If it looked like this, that would be a solid line, but this is a dashed line. Now the y-intercept is -2, and the slope is up 1 over 4. So up 1 over 4, up 1 over 4. I hope I'm counting right. So my dashed line looks something like this. Again, this is greater than. So greater than means you're going to shade above the line. So you're going to shade all of this. Remember, what does that mean? That means every point in this shaded region is a solution. Every point down here is not a solution. And what about the points on the line itself? The points on the line itself are not a solution because the line is dashed. Okay, that's all you need for this section.